Settle into your bed, adjust your pillow, and take a slow, deep breath. Tonight, we're going on a journey through our galactic home, the Milky Way. Let your eyes close gently as we drift among the stars. Take another deep breath and let it out slowly. Feel yourself sinking into the comfort of your bed. Tonight, you're going to learn about the magnificent spiral of stars we call home. The Milky Way is a barred spiral galaxy, one of billions scattered across the universe. Yet it's the only one we can truly call home. Imagine a vast pinwheel of light slowly rotating in the darkness of space, and somewhere within it, so small as to be invisible from any great distance, is our sun, our Earth, and you, resting peacefully. Our solar system is located about 26,000 light-years from the galactic center, out in the suburbs of the galaxy, in a minor spiral arm called the Orion Spur. We're not in the bustling downtown of the galaxy, but in a quieter neighborhood, where stars are more spread out, where there's room to breathe. The galaxy rotates, though so slowly that you could never perceive it in a human lifetime. Our sun takes approximately 225 to 250 million years to complete one orbit around the galactic center. This is called a cosmic year, and it's a journey of unimaginable length. Since the sun formed about 4.6 billion years ago, it has completed roughly 20 orbits around the galaxy. 20 times our sun has circled the galactic center. The last time we were in this exact position, dinosaurs had not yet appeared on Earth. The time before that, life was still in the oceans. The galaxy's disk is relatively thin compared to its width, only 1,000 light-years thick in most places, but 100,000 to 200,000 light-years across. If you made a scale model of the Milky Way the size of a dinner plate, the disk would be thinner than a sheet of paper. Our galaxy has a stellar halo surrounding it, a roughly spherical region containing old stars and globular clusters. These ancient stars orbit above and below the main disk, following elliptical paths like bees around a hive. The Milky Way has at least 150 known globular clusters. These are ancient spherical collections of hundreds of thousands of stars, all bound together by gravity. They're beautiful when viewed through telescopes, like jeweled spheres scattered around the galaxy. Some stars in these globular clusters are nearly as old as the universe itself, around 13 billion years old. They've been shining since shortly after the Big Bang, witnessing the entire history of the cosmos, and they're still burning now as you rest. The galaxy is mostly made of dark matter, an invisible substance that doesn't emit light but exerts gravitational influence. We can't see it, we can't touch it, but we know it's there because of how it affects the things we can see. Only about 10% of the Milky Way's mass is ordinary matter that we can see and touch. The rest is dark matter, mysterious and invisible, filling the space around and between the stars like an invisible ocean. The visible band of the Milky Way in Earth's night sky is actually our view of the galaxy's disk from within it. We're inside the disk, looking through it, and we see all those distant stars blurred together into a river of light across the sky. Breathe slowly now, in and out, as we continue our journey. Ancient cultures around the world saw the Milky Way's band of light and created myths about it. Some saw a river of stars, others a path of souls traveling to the afterlife. The Aboriginal Australians saw dark patches as the shapes of animals. The Cherokee saw it as cornmeal spilled across the sky. The name Milky Way comes from Greek mythology, where it was said to be milk from the goddess Hera. The Greeks called it Galaxias Kyklos, the Milky Circle, and from this we get our word galaxy. The Milky Way is moving through space at approximately 600 kilometers per second relative to the cosmic microwave background. We're all passengers on this cosmic vessel, traveling through the universe at speeds we cannot feel. Our galaxy has several satellite galaxies orbiting it, including the large and small Magellanic Clouds visible from the southern hemisphere. These are smaller galaxies, caught in the Milky Way's gravitational embrace, slowly orbiting us. The Milky Way is on a collision course with the Andromeda Galaxy, though they won't merge for another 4 to 5 billion years. Don't worry, this is so far in the future that our sun will have already swelled into a red giant by then. Let this vast timescale soothe you. There's no hurry in the cosmos. When the collision happens, the two galaxies will likely merge to form a giant elliptical galaxy, sometimes nicknamed Milkomeda. It will be a slow-motion collision, taking hundreds of millions of years, a cosmic dance of unimaginable grace. Despite containing billions of stars, the Milky Way is mostly empty space, with vast distances between each stellar point of light. If you could shrink the sun to the size of a grain of sand, the nearest star would be another grain of sand over 4 miles away. Space is incomprehensibly empty. The galaxy contains enormous clouds of gas and dust called nebulae, stellar nurseries where new stars are born. These clouds can be hundreds of light years across, glowing in beautiful colors when energized by nearby stars: crimson reds, electric blues, soft greens. Stars are still forming in the Milky Way today at a rate of about 1 to 2 solar masses per year. Right now, as you lie in bed, somewhere in the galaxy, a cloud of gas is collapsing, warming, beginning to glow. A new star is being born. The coldest known place in the Milky Way is the Boomerang Nebula, where temperatures drop to just 1 degree above absolute zero, colder than the background temperature of space itself. It's a cosmic freezer, a place of profound stillness. Our galaxy has a warped shape, not perfectly flat, likely due to gravitational interactions with satellite galaxies. If you could see the Milky Way from the side, you'd notice the disk bends slightly, like a vinyl record that's been warped by heat. The Milky Way's spiral arms aren't permanent structures, but density waves where stars and gas bunch up temporarily. Stars move into the arms, slow down, and then move out again, like cars in highway traffic. There are 4 major spiral arms in our galaxy: Perseus, Sagittarius, Centaurus, and Cygnus. Each arm contains billions of stars, gas clouds, and young star clusters, bright beacons in the galactic disk. Between the arms are regions of lower stellar density, quieter neighborhoods in the galactic city. These inter-arm regions are still full of stars, but they're more spread out, less crowded. The brightest star visible from the Milky Way's disk is actually a system in the Carina Nebula called Eta Carina. It's so luminous that it outputs as much light as 5 million suns, and it's likely to explode as a supernova sometime in the cosmically near future. Let your breathing slow. Let your body relax completely as we drift deeper into the galaxy. Our galaxy experiences several supernova explosions per century. The most are hidden from view by dust. These are the deaths of massive stars, explosions so bright they can briefly outshine entire galaxies. The oldest known star in our galaxy is called Methuselah, at nearly 14 billion years old, almost as ancient as the universe itself. This star was born when the universe was young, when the first galaxies were just beginning to form. The Milky Way's central bulge contains older, redder stars, formed in the galaxy's youth. These stars have been orbiting the galactic center for billions of years, witnessing the evolution of the entire galaxy. Magnetic fields thread through the galaxy, invisible yet powerful, influencing the movement of charged particles. These fields stretch for thousands of light years, connecting distant parts of the galaxy in ways we're only beginning to understand. Cosmic rays, high-energy particles, constantly zip through the galaxy at nearly the speed of light. They pass through you, through Earth, harmless but omnipresent, travelers from distant stellar explosions and black holes. The galaxy's rotation curve suggests that dark matter forms an extended halo around the visible disk. This invisible halo may extend hundreds of thousands of light years from the galactic center, a ghostly sphere we detect only through its gravitational effects. Scientists estimate the Milky Way's total mass, including dark matter, to be around 1 to 1.5 trillion solar masses. That's 1.5 trillion times the mass of our sun, most of it invisible, most of it mysterious. There may be as many as 100 million black holes scattered throughout the Milky Way, most of them stellar mass, the remnants of massive stars that died in supernova explosions. They drift through the galaxy, invisible, detectable only when matter falls into them. Hypervelocity stars occasionally get flung out of the galaxy at speeds exceeding escape velocity. These are cosmic wanderers, stars traveling so fast they'll eventually leave the Milky Way entirely, heading into the void of intergalactic space, alone. The Milky Way likely formed about 13 billion years ago, shortly after the Big Bang. It began as a clump of dark matter and gas, slowly collapsing under its own gravity, fragmenting into the first stars. Our galaxy grew by merging with smaller galaxies over billions of years, a process that continues today. The Milky Way is a cannibal, consuming smaller galaxies that venture too close, incorporating their stars into its own structure. Stellar streams, visible in the galaxy's halo, are the remnants of smaller galaxies torn apart by the Milky Way's gravity. These streams of stars orbit the galaxy in long, thin paths, ghosts of galaxies past. The Sagittarius dwarf elliptical galaxy is currently being consumed by the Milky Way. Its stars are being stripped away, one by one, added to the Milky Way's halo. In a few more orbits, it will be completely absorbed. From a dark location on Earth, the Milky Way's band is bright enough to cast shadows. On a moonless night, far from city lights, you can see your shadow on the ground cast by the light of billions of distant suns. Light pollution prevents most people in developed countries from seeing the Milky Way clearly anymore, but it's still there, always there, waiting for dark skies and clear nights. Feel yourself drifting, floating among the stars, perfectly safe, perfectly calm. The galaxy contains planets beyond counting, with estimates suggesting more planets than stars. Nearly every star you see in the night sky likely has at least one planet orbiting it. Some have many. Many of these planets likely orbit in habitable zones where liquid water could exist on their surfaces. These are worlds where life, if it arose, could potentially survive and thrive. The search for life in our galaxy continues through programs like SETI, listening for signals from other civilizations. Radio telescopes scan the skies, listening for patterns that couldn't be natural from messages from distant worlds. If intelligent life exists elsewhere in the Milky Way, the vast distances mean their signals might take thousands of years to reach us. A civilization 5,000 light years away could be sending us messages right now, and we won't receive them for 5,000 years. The Gaia Space Telescope has mapped over 1 billion stars in the Milky Way, charting their positions and movements with unprecedented precision. It's creating a three-dimensional map of the galaxy, showing us how stars move over time. These measurements reveal that the galaxy is a dynamic place, with stars moving in complex patterns. Some stars orbit in neat circles, others in elongated ellipses. Some move perpendicular to the galactic disk, bobbing up and down. Some stars orbit the galactic center in the same direction as the galaxy rotates, while others move in retrograde orbits, going against the flow. These retrograde stars likely came from smaller galaxies that were absorbed by the Milky Way. The galaxy's disk shows evidence of past collisions, with ripples and waves frozen in the stellar distribution. About 2 to 3 billion years ago, a smaller galaxy passed through the Milky Way's disk, and we can still see the ripples it created. At the very center, within Sagittarius A star, matter occasionally falls in, creating brief flares of radiation. But most of the time, the central black hole is quiet, not actively feeding. The region around the central black hole is surprisingly quiet compared to the active galactic nuclei found in some other galaxies. Some galaxies have black holes that are actively consuming vast amounts of matter, creating brilliant jets of radiation. Ours is relatively peaceful. Vast molecular clouds in the galaxy contain the raw materials for future generations of stars. These clouds are cold, dark places, but they're where stars are born, where the cycle of stellar life begins again. One such cloud, called the Ophiuchus cloud, is forming new stars at this very moment. If you could visit this cloud in a spaceship, you'd see cocoons of dust beginning to glow, protostars warming up, planets beginning to coalesce. Young star clusters eventually drift apart over millions of years, their members dispersing into the galactic background. The gravitational bonds between cluster members are weak, and eventually they go their separate ways. Our sun was likely born in such a cluster about 4.6 billion years ago. It had siblings, thousands of them perhaps, all born from the same cloud, but they've scattered now, lost in the galaxy, impossible to identify. Binary star systems are common in the Milky Way, with many stars having stellar companions. Two stars orbit each other, locked in a gravitational dance that can last billions of years. Breathe deeply. Let your muscles relax completely. Feel yourself floating in the gentle darkness of space. Some systems contain 3, 4, or even more stars locked in gravitational dances. These multiple star systems can be complex, with stars orbiting in intricate patterns, creating wild variations in light and temperature for any planets that might exist. White dwarfs, the cooling remnants of stars like our Sun, number in the billions throughout the galaxy. These are the dense cores of dead stars, no longer fusing elements, just slowly radiating away their remaining heat over trillions of years. Neutron stars, incredibly dense stellar corpses, spin rapidly, some pulsing hundreds of times per second. A teaspoon of neutron star material would weigh as much as Mount Everest. They're the densest objects in the universe besides black holes. The Milky Way's magnetic field may help protect us from some cosmic rays originating outside the galaxy. Like a shield, it deflects some of the high-energy particles that stream through intergalactic space. dust lanes visible in photographs of the Milky Way are actually dense clouds blocking the light of background stars. These dark patches aren't empty, they're full of dust and gas, just too cold and dark to glow. These dust clouds are crucial to star formation, providing the raw material and helping regions collapse. Without dust, stars would form much less efficiently, and the galaxy would look very different. The galaxy is home to organic molecules, the building blocks of life, floating in interstellar space. Simple molecules like water and carbon monoxide are common, but complex organic molecules have also been found. Amino acids and other complex molecules have been detected in molecular clouds. These are the building blocks of proteins, the machinery of life. They form naturally in space, suggesting that the ingredients for life are common throughout the galaxy. The Milky Way's structure has inspired countless works of art, music, and literature throughout human history. From ancient myths to modern science fiction, the galaxy has captured human imagination for as long as we've looked up at the night sky. Indigenous cultures worldwide navigated by the stars and held deep knowledge of the Milky Way's patterns. The Polynesians crossed vast oceans using stellar navigation. The Inca organized their society around celestial patterns. The galaxy appears different from different locations on Earth, with the southern hemisphere offering views of the dense galactic center. From the northern hemisphere, the galactic center passes lower on the horizon, and southern observers get a more dramatic view. The best time to view the Milky Way from the northern hemisphere is during summer months, when the galactic center is visible. The center rises in the south, dense with stars, dramatic and beautiful. In winter, we're looking outward toward the galaxy's edge, seeing fewer stars and less gas. The winter Milky Way is dimmer, but still beautiful, arcing overhead through constellations like Orion and Gemini. The Milky Way belongs to a cosmic neighborhood called the Local Group, containing about 54 galaxies. These are our nearest galactic neighbors, bound together by gravity. Within the Local Group, the Milky Way is the second largest galaxy after Andromeda. Together, these two spiral galaxies dominate the group, with dozens of smaller galaxies orbiting around them. Let your thoughts drift like stardust. There's nowhere you need to be, nothing you need to do.
The Local Group itself is part of a larger structure called the Virgo supercluster, a vast collection of galaxy groups and clusters spanning 110 million light-years. We're on the outskirts of this supercluster, in a relatively quiet region. Recent mappings suggest we're actually part of an even larger structure called Laniakea, which means immeasurable heaven in Hawaiian. This supercluster contains 100,000 galaxies and spans 520 million light-years. Despite these vast cosmic neighborhoods, the space between galaxies is mostly empty. The typical distance between galaxies is millions of light-years compared to the 100,000 light-year diameter of the Milky Way. Intergalactic space contains only a few atoms per cubic meter on average. It's emptier than the best vacuum we can create in laboratories on Earth. The cosmic void is truly void. The Milky Way radiates across the electromagnetic spectrum, from radio waves to gamma rays. Each wavelength tells a different story about the galaxy, revealing different phenomena. Each wavelength reveals different aspects of the galaxy, from cool gas to hot stellar winds. In radio waves, we see cold hydrogen gas. In infrared, warm dust. In X-rays, hot gas and energetic processes. Radio telescopes can peer through dust clouds that block visible light, revealing hidden regions. The galactic center, obscured by dust and visible light, becomes clear when observed in radio waves. X-ray observations show high-energy phenomena like matter falling into black holes, supernova remnants, and the hot gas between stars. The X-ray sky looks completely different from the visible light sky. The galaxy's infrared glow comes from dust warmed by starlight, tracing spiral arms and star-forming regions. Infrared observations show us where stars are being born, hidden inside cocoons of dust. Some of the Milky Way's stars have been around long enough to see dramatic changes in the galaxy. The oldest stars were born when the galaxy was young, and they've witnessed its entire evolution. The Sun has witnessed approximately 20 galactic rotations since its birth, each lasting 250 million years, 20 times around the galactic center, each orbit a vast journey through space. During one cosmic year, continents drift thousands of kilometers, species evolve and go extinct, ice ages come and go. A cosmic year is almost incomprehensibly long by human standards. The last time Earth was in this position in its galactic orbit, dinosaurs walked the planet. 225 million years ago, all the continents were joined into Pangaea, and the first dinosaurs were just appearing. Our galaxy will look very different in the distant future as it merges with Andromeda. The night sky will be transformed with two galaxies visible, intertwining in a slow cosmic dance. Even during that collision, actual stellar collisions will be rare due to the vast spaces between the stars. Stars will pass by each other like ships in the night, never coming close enough to touch. Feel the gentle pull of sleep, your body heavy and relaxed, your mind quiet and peaceful.
The night sky will be spectacular during the merger, with the two galaxies visible as they intertwine. Future astronomers will have an incredible view, watching the collision unfold over millions of years. Eventually, most galaxies in the local group will merge into one massive galaxy. Triangulum, the third large spiral in our neighborhood, will likely also be absorbed. The result will be a giant elliptical galaxy. The Milky Way's fate is tied to the expansion of the universe and the nature of dark energy. Dark energy is pushing the universe apart, accelerating its expansion, and this will determine the ultimate fate of all galaxies. In the far future, the galaxy may become isolated as cosmic expansion accelerates. Other galaxy groups will recede from us, driven away by the expansion of space itself. Trillions of years from now, other galaxies will have receded beyond visibility. Future observers in our merged galaxy will see a universe that appears empty, with only local stars visible. But that's so far ahead that entire cycles of stellar birth and death will repeat countless times. Stars will be born, live, and die. New generations of stars will form from the remnants of old ones. For now, the Milky Way continues its ancient rotation, a cosmic wheel turning in the darkness. It has been rotating for 13 billion years, and it will continue for billions more. Each star in our galaxy has its own story, its own journey through space and time. Some stars are solitary travelers, others have companions. Some have planets, others do not. We're part of this story, residents of a small blue world orbiting an ordinary yellow star. Our sun is not special in the cosmic sense. It's a medium-sized star, middle-aged, unremarkable. Looking up at the Milky Way connects us to something vast, ancient, and magnificent. When you see the Milky Way on a dark night, you're seeing a cross-section of the galaxy, looking through the disk from within. The galactic disk is about 1,000 light-years thick, so when you look at the Milky Way, you're seeing stars within about 500 light-years above and below the plane we inhabit. The brightest stars in the Milky Way band are relatively nearby, within a few thousand light-years. The faint glow comes from billions of distant stars, their light blurred together. Dark patches in the Milky Way aren't empty, but are dense clouds of dust blocking the light of more distant stars. These dark nebulae are stellar nurseries, where new stars will eventually be born. The Great Rift, a dark band running down the Milky Way, is actually a series of overlapping dust clouds between us and the galactic center. It creates a dark lane through the brightest part of the Milky Way. The galactic bulge, the bright central region, contains billions of old stars packed densely together. Near the center, stars are so close that if you were on a planet there, the night sky would never be truly dark. Sink deeper into relaxation. Let go of all tension. Drift peacefully through the cosmos. Astronomers divide stars into populations based on their age and composition. Population 1 stars are young and metal-rich, like our Sun. Population 2 stars are old and metal-poor, formed when the galaxy was young. Metal-rich, in astronomical terms, means containing elements heavier than helium. To astronomers, anything that isn't hydrogen or helium is a metal, including carbon, oxygen, and iron. The first stars in the universe contained almost no metals at all, just hydrogen and helium from the Big Bang. These population 3 stars have never been observed, but they must have existed. When massive stars die in supernova explosions, they scatter heavy elements into space. These elements become part of new clouds, which form new stars, which are therefore richer in metals than previous generations. Our Sun is a relatively metal-rich star, meaning it's not a first-generation star. It formed from a cloud that contained the remnants of previous stars, making us made of recycled stardust. Every atom in your body, heavier than hydrogen, was forged in stars. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were created in stellar furnaces and scattered into space. Carbon, the basis of all life on Earth, is made in red giant stars. As stars age and swell, they fuse helium into carbon in their cores, creating the element that makes life possible. The heaviest elements, like gold and uranium, require even more extreme conditions. They're created in supernova explosions or in collisions between neutron stars, events of incredible violence and energy. The Milky Way has been enriching itself with heavy elements for billions of years. Each generation of stars that lives and dies adds more metals to the galactic mix. The youngest stars forming today are more metal-rich than those that formed billions of years ago. They have a higher proportion of heavy elements, making them chemically different from ancient stars. Globular clusters contain some of the oldest stars in the galaxy, and their stars are very metal-poor. This is one way we know they're ancient. They formed before the galaxy had been significantly enriched with heavy elements. Some stars in the galactic halo are so metal-poor that they must have formed very early in the galaxy's history. They're like fossils, preserving information about conditions in the early universe. The metallicity of stars can tell us about the history of the galaxy, about when and where different regions formed, about the patterns of star formation over billions of years. Our region of the galaxy has a typical metallicity for the galactic disk. We're neither in an unusually metal-rich nor metal-poor area, just an average neighborhood. The interstellar medium, the gas and dust between stars, is constantly being enriched. Dying stars return their matter to this medium, making it available for future generations of stars. Let your breathing become slow and regular. Feel yourself floating in the peaceful darkness.
Stars don't orbit the galaxy in perfect circles, but in elliptical paths that bob up and down through the galactic plane. Our sun oscillates through the disk every 60 to 70 million years. These oscillations may have influenced Earth's climate over geological time. When the solar system passes through the densest part of the disk, we encounter more dust and cosmic rays, which could affect Earth's climate. The Milky Way's rotation is differential, meaning the inner parts rotate faster than the outer parts. Stars closer to the galactic center complete their orbits more quickly than those farther out. This differential rotation would wind up the spiral arms if they were made of fixed groups of stars. But the arms are density waves, patterns that persist even as individual stars move through them. Think of spiral arms like traffic jams on a highway. Cars move into the jam, slow down, and then move out. But the jam itself persists in roughly the same location. Stars spend more time in the spiral arms because they're moving slower there, which is why the arms appear bright. There are more stars passing through those regions at any given time. The spiral pattern may be driven by gravitational interactions with satellite galaxies, or by density waves that naturally arise in rotating disk galaxies. Our solar system is currently between spiral arms, in a region sometimes called the local arm or Orion spur. We're in a relatively quiet part of the galaxy. The next time our solar system passes through a major spiral arm will be tens of millions of years from now. By then, evolution on Earth will have progressed significantly, though humans may or may not still exist. The galactic center is a crowded place, with stars packed much more densely than in our neighborhood. If Earth orbited a star near the galactic center, the night sky would contain thousands of bright stars. Near the very center, within a few light years of Sagittarius A star, there's a cluster of massive young stars. They orbit the black hole at tremendous speeds, completing orbits in as little as 15 years. These stars let us measure the mass of the central black hole by observing how fast they orbit. It's like watching planets orbit the sun. The orbital periods tell us the mass they're orbiting. Some of these central stars pass so close to the black hole that they experience significant gravitational time dilation. Time passes slightly slower for them than stars farther out. The black hole itself is surrounded by an accretion disk, though it's not currently very active. Sometimes matter falls in, creating brief flares of X-rays and radio waves. In the past, the Milky Way's central black hole may have been much more active. There's evidence of giant bubbles of hot gas above and below the galactic center, perhaps blown out by an active phase millions of years ago. Feel yourself sinking deeper, every part of your body relaxed, your mind quiet and still. Open clusters are groups of young stars born from the same molecular cloud.
They're loosely bound and will eventually disperse, but for now, they travel through the galaxy together. The Pleiades, visible to the naked eye, is a famous open cluster, about 100 million years old. It contains several hundred stars, though only the brightest are visible without a telescope. Open clusters can contain anywhere from a few dozen to a few thousand stars. They're common in the galactic disk, especially in the spiral arms where star formation is ongoing. The stars in an open cluster are all roughly the same age, formed from the same cloud of gas and dust. This makes them valuable for studying stellar evolution. Globular clusters, in contrast, are ancient and densely packed, containing hundreds of thousands of stars in a spherical region. They orbit in the galactic halo, above and below the disk. Globular clusters are among the oldest objects in the galaxy, with ages of 12 to 13 billion years. They formed when the galaxy itself was young, and they've survived unchanged ever since. The stars in globular clusters are so close together that near the center, they're separated by only a few light weeks compared to the 4 light years between our Sun and its nearest neighbor. Stellar collisions can actually occur in globular cluster cores, though they're still rare even there. When they do occur, they can create unusual objects like blue stragglers. Blue stragglers are stars that appear younger than they should be. They may be the result of stellar collisions or mass transfer in binary systems, rejuvenated by fresh hydrogen. OB associations are loose groups of massive hot stars, often found in spiral arms. These massive stars are young, bright, and short-lived, burning through their fuel in just a few million years. The Orion OB1 association includes many familiar stars, like the stars of Orion's belt and the stars that light up the Orion Nebula. These massive stars are transforming their environment with intense stellar winds. When massive stars die, they explode as supernovae, enriching the surrounding gas with heavy elements and triggering new star formation. One supernova can trigger the birth of an entire new generation of stars. Supernova remnants can be visible for tens of thousands of years, expanding shells of hot gas plowing through the interstellar medium. They're beautiful when viewed in X-rays. The Crab Nebula is a famous supernova remnant, the remains of a star that exploded in 1054 CE. Chinese astronomers recorded seeing a guest star so bright it was visible in daylight. At the center of the Crab Nebula is a pulsar, a rapidly rotating neutron star that pulses 30 times per second. It's the collapsed core of the star that exploded, spinning incredibly fast. Let go completely. Feel yourself floating weightlessly in the gentle void of space. The space between stars is not truly empty, but contains the interstellar medium, gas and dust at various temperatures and densities. This material makes up about 10 to 15% of the visible mass of the galaxy. The interstellar medium is mostly hydrogen, the simplest and most abundant element in the universe. It exists in different forms: cold molecular clouds, warm neutral gas, and hot ionized gas. Cold molecular clouds are the densest parts of the interstellar medium, where hydrogen molecules form and where stars are born. These clouds can be hundreds of light years across and contain enough mass to form thousands of stars. The temperature in these clouds can drop to just 10 to 20 Kelvin, incredibly cold, just a few degrees above absolute zero. In this cold environment, molecules can form and survive. Warm neutral hydrogen fills much of the galactic disk at temperatures around 8,000 Kelvin. This gas emits radio waves at a wavelength of 21 centimeters, allowing astronomers to map it across the galaxy. Hot ionized gas, heated by supernova explosions and stellar winds, fills the space between cold clouds. This gas is very thin but very hot, millions of degrees, and it emits X-rays. Dust grains mixed throughout the gas are tiny, smaller than smoke particles, but they're crucial for blocking light and helping molecules form. Stars and planets begin as these microscopic grains. These dust grains are made of carbon, silicon, iron, and other heavy elements, the products of previous generations of stars. They're the building blocks of planets and ultimately of life. In the densest parts of molecular clouds, dust grains get coated with ice, frozen water, carbon dioxide, and other simple molecules. These icy grains can stick together, beginning the process of planet formation. The interstellar medium is constantly cycling, with matter moving from clouds to stars, from stars back to the medium in stellar winds and supernova explosions, and then back into clouds again. This cycle has been going on for billions of years, enriching the galaxy with heavy elements, creating generation after generation of stars, a cosmic recycling program on an unimaginable scale. Shock waves from supernova explosions plow through the interstellar medium, compressing gas and sometimes triggering the collapse of clouds into new stars, death giving rise to new life. The Milky Way's interstellar medium contains enough material to continue forming stars for billions of years to come. The galaxy is not done creating, it's still an active, living place. Vast cavities blown in the interstellar medium by stellar winds and supernovae create bubbles hundreds of light years across. Our solar system actually sits inside one such bubble, called the local bubble. The local bubble was created by supernova explosions millions of years ago. We're in a region of low-density, hot gas, surrounded by denser clouds at the bubble's edge. Magnetic fields thread through the interstellar medium, guiding the motion of charged particles and influencing how clouds collapse to form stars. These fields are invisible but pervasive. Breathe slowly, in through your nose, out through your mouth. Let every breath carry you deeper into peace.
Emission nebulae glow with vivid colors because their gas is energized by nearby hot stars. The Orion Nebula, visible to the naked eye, is the most famous example, a stellar nursery 1,300 light-years away. The Orion Nebula is forming new stars right now, with thousands of young stars and protostars hidden within its gas and dust. Some are just beginning to shine, while others are still gathering mass. The nebula glows red from hydrogen, the most common element, which emits red light when energized. Oxygen emissions add green and blue tints, creating the nebula's characteristic colors. Reflection nebulae don't emit their own light, but reflect the light of nearby stars. They appear blue because dust scatters blue light more efficiently than red, the same reason Earth's sky is blue. Dark nebulae are clouds so dense they block background light entirely, appearing as dark patches against the star field. The famous Horsehead Nebula is a dark nebula silhouetted against glowing gas.
Planetary nebulae have nothing to do with planets, but are the beautiful shells of gas expelled by dying sun-like stars. They glow as the hot stellar core illuminates the expanding shell. The Ring Nebula and the Cat's Eye Nebula are famous planetary nebulae, showing the intricate structures that form as stars die. These objects are relatively short-lived, fading after about 10,000 years. Supernova remnants are the expanding shells of gas from exploded stars. The Veil Nebula is a supernova remnant, the remains of a star that died about 8,000 years ago, now spread across 3 degrees of sky. These remnants expand at thousands of kilometers per second, crashing into surrounding gas, creating shock waves that heat the gas to millions of degrees. Inside supernova remnants, conditions are extreme enough to accelerate cosmic rays to nearly the speed of light. These particles then travel through the galaxy for millions of years. Herbig-Haro objects are jets of gas shot out by newborn stars, traveling at hundreds of kilometers per second. They create glowing shock waves as they slam into surrounding gas. These jets help remove excess angular momentum from forming stars, allowing the star to continue pulling in material from its surrounding disk without spinning itself apart. Protoplanetary disks surround young stars, flattened disks of gas and dust where planets are forming. Our solar system formed from such a disk 4.6 billion years ago. The Hubble Space Telescope has photographed hundreds of protoplanetary disks in the Orion Nebula and other star-forming regions, showing us planetary systems in the process of being born. These disks are typically a few hundred astronomical units across, with the inner regions hot enough to vaporize rock and the outer regions cold enough for ices to form. In these disks, dust grains collide and stick together, gradually growing larger. Pebbles become boulders, boulders become mountains, and eventually, planets emerge. The process takes millions of years, from the first dust grains sticking together to the final clearing of the disk as planets sweep up the remaining material. By the time a star is a few million years old, its planets are mostly formed, and the remaining gas in the disk has been blown away by stellar winds or incorporated into giant planets. Every star you see in the night sky likely has planets orbiting it. The galaxy is full of worlds, billions upon billions of them, each unique. Some of these planets are likely rocky worlds like Earth, orbiting in their star's habitable zone where liquid water could exist. Some may harbor life. Let yourself drift, peaceful and calm, surrounded by the gentle light of distant stars.
Astronomers have discovered thousands of exoplanets, planets orbiting other stars. The Kepler Space Telescope alone found over 2,600 confirmed planets during its mission. These planets come in stunning variety. Hot Jupiters orbiting closer to their stars than Mercury orbits our sun, super-Earths larger than our planet, ice giants, lava worlds, planets orbiting binary stars. Some exoplanets orbit in their star's habitable zone, the region where temperatures allow liquid water on the surface. These are the most interesting in the search for life. The nearest potentially habitable exoplanet is Proxima Centauri b, orbiting the closest star to our sun, just 4.2 light-years away. It's a rocky world, though we don't yet know if it has an atmosphere. Many exoplanets orbit red dwarf stars, the most common type of star in the galaxy. These stars are small and cool, but their habitable zones are close in, so planets there might be tidally locked. A
tidally locked planet always shows the same face to its star, like the moon always shows the same face to Earth. One side would be in permanent daylight, the other in permanent night. Some scientists think such planets could still be habitable, with heat from the day side transferring to the night side through atmospheric circulation. The TRAPPIST-1 system contains 7 Earth-sized planets, 3 of them in the habitable zone. This system, 40 light-years away, is one of the most intriguing targets in the search for life. Future telescopes will be able to analyze exoplanet atmospheres, looking for biosignatures, signs of life such as oxygen, methane, and other gases that might indicate biological activity. The James Webb Space Telescope has already begun studying exoplanet atmospheres, detecting water vapor, carbon dioxide, and other molecules in the air of distant worlds. If life exists elsewhere in the galaxy, it might be very different from life on Earth. It might use different chemistry, different solvents, different energy sources. But the basic requirements are likely the same: a source of energy, a solvent like water, and organic chemistry. These ingredients exist throughout the galaxy. The building blocks for life are common in space. Amino acids have been found in meteorites and comets, and complex organic molecules exist in interstellar clouds. This suggests that life's ingredients are widespread, making it more likely that life has emerged elsewhere in the galaxy. The universe seems predisposed to chemistry that could lead to biology. Whether intelligent life exists elsewhere is a bigger question. Life might be common, but intelligence rare, or perhaps civilizations are common, but short-lived. The Fermi paradox asks, if intelligent life is common, where is everybody? We've seen no signs of alien civilizations, no radio signals, no evidence of megastructures or interstellar travel. Perhaps intelligent civilizations are rare, or perhaps they don't last long, or perhaps they're there, but we haven't recognized their signals yet. Or perhaps space is simply too vast, the distances too great, the timescales too long for civilizations to easily find each other. The Milky Way is 100,000 light-years across, meaning a signal from the far side would take 100,000 years to reach us. Civilizations could exist, but be too far away to detect. For now, we listen and search, scanning the skies for signals, analyzing starlight for signs of artificial structures, wondering if somewhere out there, someone is wondering the same thing. Feel your body becoming heavy, sinking into your bed, every muscle relaxed, every thought quieting.
The galaxy functions like an ecosystem, with matter and energy flowing through it in cycles. Stars are born, live, and die, returning their matter to the interstellar medium. Massive stars live fast and die young, burning through their fuel in just a few million years before exploding as supernovae. They're the galaxy's manufacturers of heavy elements. Low-mass stars like red dwarfs are misers with their fuel, burning so slowly they can last for trillions of years. None of them have died yet. The universe isn't old enough. Sun-like stars live for about 10 billion years, fusing hydrogen into helium in their cores, then swelling into red giants, before gently puffing off their outer layers as planetary nebulae. The Sun is about halfway through its life, at 4.6 billion years old. It has another 5 billion years of stable burning ahead of it before it begins to change. Eventually, the Sun will swell into a red giant, growing so large it will engulf Mercury and Venus. Earth may or may not be consumed, but either way, it will be scorched, lifeless.
After the red giant phase, the Sun will shed its outer layers, creating a planetary nebula. The core will shrink down to a white dwarf, slowly cooling over trillions of years. White dwarfs are incredibly dense. A teaspoon of white dwarf material would weigh about 5 tons. They're supported not by fusion, but by electron degeneracy pressure. Eventually, white dwarfs cool and fade, becoming black dwarfs, cold, dark, stellar remnants. But this takes so long that no black dwarfs exist yet in the universe. The most massive stars end as black holes, their cores collapsing so completely that not even light can escape. These stellar mass black holes drift through the galaxy invisibly. Black holes can be detected when they have companion stars, pulling matter from the companion in an accretion disk that heats up and glows in X-rays. The galaxy is a graveyard as well as a nursery, filled with the remnants of dead stars, white dwarfs, neutron stars, black holes, all wandering through space. But it's also a place of renewal, where the ashes of old stars become the seeds of new ones. Every atom in a new star was once part of an old star. This cosmic recycling has been going on for billions of years, gradually enriching the galaxy with heavy elements, making planets possible, making life possible. The first stars contained almost no heavy elements, so they couldn't form rocky planets. There were no planets like Earth, no possibility for life as we know it. As generations of stars lived and died, the galaxy's metallicity increased. Eventually, conditions became right for planets like Earth to form. Our solar system formed 4.6 billion years ago from a cloud enriched by previous generations of stars. We're made of recycled stardust. The calcium in your bones was made in a dying star, perhaps billions of years ago. The iron in your blood was forged in a supernova. You are literally made of stars, a collection of atoms that have been through cosmic cycles of creation and destruction, now temporarily assembled into the form of a conscious being. And someday, those atoms will return to the cosmos, scattered back into space, to eventually become part of new stars, new planets, perhaps new life. Let this knowledge comfort you. You're part of an ancient cycle, connected to the cosmos, drifting peacefully.
The Milky Way's future is tied to Andromeda, our nearest large galactic neighbor. The two galaxies are approaching each other at about 110 kilometers per second. In about 4 billion years, Andromeda will fill the night sky, a spectacular sight as the two galaxies begin their gravitational dance. The collision will last hundreds of millions of years, with the galaxies passing through each other, their stars intermixing like two swarms of bees. Despite the collision, actual stellar collisions will be extraordinarily rare. Stars are so small compared to the distances between them that most will pass by without incident. But the gravitational interactions will be dramatic, flinging stars into new orbits, triggering massive bursts of star formation as gas clouds collide and compress. The night sky will be spectacular, with regions of intense star formation glowing in brilliant colors, and with stars from both galaxies creating new constellations. Eventually, after several passes, the two galaxies will merge completely, forming a giant elliptical galaxy. The spiral structure will be lost, replaced by a more spherical distribution of stars. Our Sun will likely survive this merger, flung into a new orbit in the merged galaxy. Earth, if it still exists, will have an entirely different view of the cosmos. But this is billions of years in the future, an almost incomprehensible amount of time. Our Sun will have already begun its red giant phase by then.
life on Earth will have ended long before the merger, not from the collision, but from the sun's natural evolution. In about 1 billion years, the sun will be hot enough to boil Earth's oceans. Unless life finds a way to leave Earth, to spread to other worlds, it will end when Earth becomes uninhabitable. But 1 billion years is a very long time. After the merger with Andromeda, the new galaxy will continue evolving, with stars continuing to form from remaining gas, though the gas supply will gradually be depleted. Eventually, billions of years later, star formation will slow and stop as the gas is used up and no new material falls in. The galaxy will slowly grow darker. White dwarfs will become the most common type of star, with most sun-like stars having ended their lives. Red dwarfs will still burn, but they're dim. On timescales of trillions of years, even the longest-lived stars will burn out. The universe will enter what's called the degenerate era, where white dwarfs, neutron stars, and black holes are the only stellar remnants. Eventually, even white dwarfs will cool completely, becoming black dwarfs, cold and dark. The galaxy will become a vast collection of dead stars and black holes. Protons might eventually decay, though this hasn't been observed and might take 10 to the 34th years or more. If they do, even dead stars will eventually evaporate into radiation. Black holes will be the last objects to survive, slowly evaporating through Hawking radiation over timescales of 10 to the 100 years or more. But this is so far in the future that it's almost meaningless, a time so distant that the current age of the universe is less than a blink by comparison. For now, on this quiet night, the Milky Way continues its ancient rotation. Stars shine, planets orbit, and perhaps, somewhere, life looks up at the sky and wonders. The galaxy is 13 billion years old, ancient beyond comprehension, yet still young compared to how long it will endure. Breathe slowly, let your thoughts fade, surrender to sleep.
We live in a special time when the galaxy is still alive with star formation, when the night sky is dark enough to see other galaxies, when the universe is neither too young nor too old. Our location in the galaxy is remarkably safe, far from the chaotic center, in a relatively quiet region with a stable star and a circular orbit. If we lived near the galactic center, radiation levels would be much higher, supernovae more frequent, and the gravitational environment more chaotic. If we lived in a globular cluster, the night sky would be spectacular with thousands of bright stars, but the environment might be hostile to life. Instead, we orbit in the galactic suburbs where space is relatively empty, where our star has orbited peacefully for 4.6 billion years, giving life time to evolve. Earth has been remarkably stable, with a large moon to stabilize its rotation, a protective magnetic field, and a location in the habitable zone. All of this allowed life to emerge and persist, to evolve from simple cells to complex creatures, to eventually produce beings capable of understanding the cosmos. We are the universe become conscious, matter arranged in such a way that it can contemplate itself, can understand the stars, can wonder about its place in the cosmos. Every human who has ever lived has looked up at the Milky Way, from prehistoric humans to modern astronomers. It's a shared experience across all cultures and all times. The same stars that ancient humans saw are still shining, though they've moved slightly in their orbits. The galaxy turns slowly, but some things remain constant. The knowledge that we're made of stardust is both humbling and awe-inspiring. We're not separate from the cosmos, but intimately part of it. The atoms in your body have been through incredible journeys, forged in stellar cores, scattered by supernovae, gathered into clouds, incorporated into planets, and now temporarily part of you.
Those atoms will continue their journey after you, returning to Earth and eventually, in the far future, perhaps becoming part of other stars, other worlds. In this way, we're all connected to each other, to Earth, to the Sun, to the galaxy, to the universe itself. We're all made of the same stuff, all part of the same cosmic story. The Milky Way is our home on the largest scale, the galactic neighborhood where our species evolved, where all of human history has unfolded. Every person you've ever known, every story ever told, every empire that rose and fell, all of it happened in one tiny corner of this vast galaxy. And yet, the galaxy is just one of billions scattered through the observable universe like grains of sand on a cosmic beach. The universe is vast beyond comprehension, filled with wonders we've barely begun to explore, questions we've barely begun to ask. But tonight, you don't need to understand it all. You can simply rest in the knowledge that you're part of something magnificent. The galaxy turns slowly overhead, whether you can see it or not. Billions of stars shine in the darkness, their light traveling through space for years, centuries, millennia. Some of that light is reaching Earth right now, photons that began their journey when dinosaurs roamed, when humans were first learning to walk upright, when our ancestors were still swimming in ancient seas. The universe is patient and vast, and you are a small but precious part of it, a temporary arrangement of stardust that can think and feel and wonder. Rest now, knowing you're cradled by gravity, protected by Earth's atmosphere, warmed by our sun, part of a solar system orbiting through the galaxy. You're traveling through space at hundreds of kilometers per second, though you can't feel it. Earth spins, orbits the sun, and the sun orbits the galactic center. We're all on a cosmic journey together, riding aboard spaceship Earth through the vastness of space and time. And for now, for this night, you can simply rest. Close your eyes, take slow breaths, and drift into peaceful sleep among the stars of the Milky Way. Rest well.